So we are given two lines. Actually, it turns out we don't really need the two lines. C be the locus of points such that the product of distance of P from L1 and L2 is lambda square. So let the point be x comma y. Distance of the point from line L1 would be x root 2 plus y minus 1 by root 3, and the distance from L2 would be plus y minus 1 by root 3, and this should be lambda square. So we have the locus of the point. It simply becomes 2x square minus y minus 1 squared is 3 lambda square. So we have C. Then the line y equals to 2x plus 1 meet C at 2 points R and S, and the distance between R and S is root 70. So y equals to 2x plus 1. We need to solve C with this line. That gives us y minus 1 equals to 2x. Substituting this here, we get 2x square minus 2x square 3 lambda square, which gives us the x coordinate of the point of intersection as x square equals 3 lambda square by 2. So the distance between R and S would be under root x1 minus x2 squared plus under root y1 minus y2 squared. We have y1 equals to 2x1 plus 1 and y2 equals to 2x2 plus 2. So the difference between them would be 4 times x1 minus x2 squared. Or the square of the difference between them would be this. So this becomes root 5 times modulus of x1 minus x2, where x1 and s2 are roots of this equation. So that gives me 2 root 5 into root 3 by 2 lambda. Or we just need the square. So this is the distance between the 2 points. So root 5 times x1 minus x2 squared equals to 270, and we have x1 equals to root 3 by 2 lambda, x2 is minus root 3 by 2 lambda, so x1 minus x2 is root 6 lambda. Root 6 lambda square is 270, gives me lambda square equals to 9. So we have lambda square. Okay. So this becomes 27, and answer of 9 lambda square is 9. We need to find the answer of 10th question. So now we want the perpendicular bisector of RS. So recall that R was, okay, I shouldn't have removed them. So we have x1 and x2. So say R is root 3 by 2 times lambda, S is root 3 minus root 3 by 2 times lambda, and 2 times this would be root 6 lambda plus 1 and 1 minus root 6 lambda. These are the coordinates of R and S. Then the perpendicular bisector of RS would be passing from 0, 1, the midpoint of RS, and would be perpendicular to the line y equals to x plus 1. So that would be x plus 2y equals to 2. So we have perpendicular bisector. Now we can get rid of all this. And then we need to solve this line with the curve C. So we don't need any of this. Now we want to solve this with the line x plus 2y equals 2. So again, and we have lambda square is 9. We can write this as 27. Again, substituting this here, we get 2x square minus, now y, 1 minus y, which means 1 minus y equals to x by 2. So that goes here. I get this on this square gives me modulus of x squared is 27 into 4 by 7. Again, note that x and minus x naught and minus x naught would be the solutions for this. So the distance between r prime and s prime could be written as x naught minus x naught squared plus y is y naught which would be written as 1 minus x naught by 2 minus 1 minus x naught would become this squared. So this becomes 4x naught square plus x naught square, which becomes root 5 x naught, where x naught square is this. Then d is the square of this distance between them, which is 5 times x naught square, which is 5 times 27 into, which is 540 by 7, which is 77 times 1 plus 1 by 7, which is this. So the answer of this is 4. Yeah.